Companies like OpenAI and DeepSeek spend tens of millions of dollars and utilize thousands of GPUs to train their massive language models. But data shows an 8 billion parameter model trained on a personal computer for under $5 can outperform massive systems in specific business tasks. Take this custom output from a specialized AI trainer. When tasked with creating a 30-minute workout, it doesn't give a generic fitness article. It immediately generates exact warm-ups, main circuits, specific rep counts, and supersets tailored precisely to the user's available equipment. To achieve these results for your own business, you do not need a server farm. You only need a free Google account, a single file containing about 200 to 500 examples of your own data, and about 10 minutes of setup. Massive computing power is becoming secondary to specialized context. When a smaller model is trained on the specific nuances of your operations, it operates with a level of precision that general-purpose AI cannot match. Most fine-tuning attempts fail because users attempt to force their data into complex JSON files or nested data structures. This complexity is unnecessary and often leads to formatting errors that break the training process. This layout requires a spreadsheet with 2 columns. The first holds the input text, like a user's prompt for a 30-minute dumbbell workout. The second holds the desired output, blueprinting the exact structure the AI must mimic, including warm-ups, main circuits, and supersets. You only need a few hundred of these pairs in a CSV file to see results. Success here is determined by absolute structural simplicity, rather than the volume of raw text. With the CSV ready, we move to the Unsloth Google Colab notebook. This platform allows you to perform the training using a T4 GPU without any hardware costs. Once you open the notebook, run the setup cell exactly as it is. This installs the necessary libraries and prepares the environment for the training. Next, scroll to the model selection cell. For this process, we are choosing the Meta Llama 3.1 8 billion parameter model from the provided list. After selecting the model, run the cell that adds the LoRA adapters. These adapters act as the bridge, allowing the base model to absorb and learn from your custom CSV data without needing to rebuild the entire model from scratch. The notebook provides the vehicle, while the LoRA adapters allow you to inject your specific business knowledge directly into the model's logic. We now reach a critical point in the code. If the variable names in the training script do not match your CSV column headers exactly, the training will fail. Look at the section and update the mapping block. Change the labels to instruction and output, or whatever names you gave your spreadsheet columns, to ensure the script can find your data. Run the print command directly below this block. You should see a single row of your custom data appear in the output window. If you don't see your specific text here, the mapping is incorrect. Now we must adjust the training parameters. Using the default settings for a small dataset will often result in the model generating incoherent text or hallucinations. On the configuration dashboard, set epochs to 2 so the model analyzes data twice. Increase warm-up steps to 50 to help it stabilize. Set accumulation steps to 8 and batch size to 2. Finally, lower the learning rate to capture your brand voice accurately. Click Run to start the training. As the process runs, monitor the loss numbers in the log. A steady decrease in these numbers is the mathematical proof that the model is successfully learning your provided format. Precision in these settings ensures that the AI exits the process as a specialist rather than generating random text. After about 9 minutes of processing, the training is complete. We can now navigate to the final testing cell to verify the model's performance. We will input a prompt that the model hasn't seen yet. Give me a 30-minute garage workout limited to a pull-up bar and dumbbells. The live output shows the result. The model ignored general fitness advice and followed our brand voice perfectly, producing a structured routine of toes to bar and dumbbell thrusters that matched our exact equipment constraints. This specialization is why fine-tuned models can outperform GPT-4 by over 50% in accuracy for specific tasks. In studies of stance classification, for example, these specialized models achieved 94% accuracy, while the largest general models struggled to reach 61%. You can now export this model to be integrated into your own business tools, from customer support systems to automated content generation workflows. To learn more about deploying these models and accessing pre-built automations, you can join the waitlist for our community using the link below. The future of AI implementation belongs to those who focus on specific context over massive scale. By building your own specialist tools today, you can solve business problems that general models still struggle to handle.